So for this lab, you have to do this page before you can do the circles on this page. So what I mean is you have to know how far away the earthquake is before you can draw the circle around the city. So at the freaking heck, there's water all. Heck. Anyway, well, that's not gonna help. All right. Sorry, water tragedy. All right. So this is a seismogram. They're the little squiggles that are made by the machine when the earth starts shaking. They've labeled for you when the P wave and when the S wave get there. So here's how I operate this. I bring down, so right underneath the P is when the P wave gets there. Right underneath the S is when the S wave gets there. I don't like to leave this up to chance. I put those little marks so I can see exactly where they are on the number line. Now, we have to figure out when each wave gets there, the P wave arrival and the S wave arrival. Some of these numbers are labeled. Here it says 0, 20, 0. What does this 0, 20, 0 mean? It's, okay, so this is officially like midnight. We would have written it like this. And we would have said AM. That's how we would have written that. So this is midnight, 20 minutes after midnight. So this number over here, the next one that's labeled is 12:25 AM. So we need to know what those little lines are going up by because they only labeled every 5. So here's 20 and 25. What are these little lines going up by? 1 minute. So this is 12:21, 22, 23. Wait, 21, 2, 23. What is that? Oh, this is why. Here's 20. Sorry. So 20, 21, 22, 23, 24, 25. Wow, it's hard to teach when you mess it up yourself, huh? So they're going up by 1 minute. So on that note, what is the P wave arrival? What time? Yeah, that's right on the 21 mark. So I'm just going to write that up here. 12:21, 0. Oh, actually, I can write it here. And they are actually only asking for the minutes and seconds. So that's 21 minutes and 0 seconds. Now we're going to do the same thing for the S. Does the S wave get there right on 30? No, it's a little bit past. So here's 30. Here's 31. What would you estimate that S to be at? Yes. So it's 30 minutes and 10 seconds. Right. So then you have to do, and I know this is going back a ways. We did this, Mr. Miga's class did this back in November. We did it in early December, but you still are responsible for knowing it. So to do the difference, you just subtract. So 30, 10 minus 21, 0 is 9 minutes and 10 seconds. Then you take this to your reference table. So remember, when you get the difference, that's telling you to grab scrap paper. So you take your scrap paper, line it up on the y-axis. You mark off the 0, mark off 910, which 920 is the first line. So we're between the 9 and the 920. I label these so I don't forget what I'm doing. Then you slide it up and over. So you kind of wedge it in between these two lines and see where it fits really good. So it's really close here at 8,000, but it's not exactly. So I go down a little. For me, right there on that line is where it fits the best. Follow that down. It's the 7,800 line. If you said 7,900, you're okay. If you said 8,000, I'll even take it. Yeah. No. 6 minutes and 45 seconds? No, because that's not the difference. The difference is 9 minutes and 10 seconds. We're not on the New York one. Hang on. So that's, now we know the earthquake is 7,800 kilometers from San Jose. That tells us we are 7,800 miles from San Jose, but that could be 7,800 this way, or that 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 way. So if you remember back to when we did this, that means you have to draw a circle around San Jose with a radius of 7,800. To do this, you're going to need a compass. I know in math class, Mr. Drake or whoever else you have for a teacher gives you a different kind of compass, but unfortunately for earth science, you have to use these compasses. So everybody come on up and grab a compass. I understand that. That's why I'm doing this now. But if you had watched the video, you would have realized you would have needed this, and then you could have asked, and then we would have gotten them for you. Just saying. So these compasses, they have a rule. So first of all, they're really cheap, and it means they're really breakable. So please don't treat them like a fidget toy. Thanks. The other thing is they are really cheap and they are pretty breakable. So if you drop them on the ground, they probably will break. I know accidents happen. Just let me know so I can either fix them or break them apart to use their parts to fix a different one. So with these compasses, you'll see on them that there's a ruler on them. We're going to ignore the ruler because that would be making a circle that has a radius of 3 centimeters or 1 inch. We don't want to do centimeters and inches. We need to use the map scale. So with these compasses, there's a couple parts to them. You'll see, I call this part the bullseye. If you're used to Mr. Drake's compasses, they have a pointy end to them. That pointy end is the part that doesn't move. That's equivalent to the bullseye. This is the part that's not going to move. So this is going to be where our cities are located. You'll notice this little knob here. You can turn this and it makes it so you can slide the compass back and forth. What we're going to do is we need to open our compass to 7,800 kilometers, and you're going to do that by looking at the scale. So the first part would be finding approximately 7,800. So here's 7,000, here's 8,000. So 7,800 is in between those two. I like to draw this larger line just so I don't have to look for it later. Guys, right here probably is what you're looking for. With this compass, I call this the crack, this 90 degree angle right here. If you put that right on 0, right in the crack there, you can now slide your compass so that one of these holes lines up perfectly with the 7,800 mark. So go ahead and do that. Once you're where you're comfortable that it's 7,800, you kind of have to let go with one hand and tighten the blue knob so it doesn't move. So now your compass is open to 7,800. Does anybody need help getting that part done? Some of your compasses are probably broken and you might not be able to tighten them down. If that's the case, come grab a different one. Yeah, they're really, really cheap compasses. So once you're open to 7,800, you're going to put the bullseye, which again is this part. This goes over whatever city you're doing this for. So the 7,800 was for San Jose. Now, in case you can't find San Jose, it's down here by the 5,000 mark. In fact, I think the dot is right above the 5. So you put the bullseye over San Jose. Now, I don't think I pointed this out. There's 2 different holes here. It doesn't matter which one you use as long as whichever one you measured with. So when I did this, I measured with the outside hole. So as long as it doesn't matter which one you measure with, as long as you remember which one you use. So I use the outside hole. So I'm going to put the bullseye over San Jose. Hold that down. Don't let the bullseye move. Stick your pen into whichever hole you measured with. So I used the outside hole and just slide it around. So you're holding down the bullseye and sliding your pen around, and you'll get a very large circle. Yep, it'll go off the paper. Hint, the earthquake's not over on the desk, so don't draw on the desk, please. And you should get something that looks like that. Now you're going to do this for the other two cities. So I'm not going to do that for you, but you're going to go back and hopefully you already have this filled in. If you don't, you will get it. Go do it now. And you'll have a measurement for New York and a measurement for San Francisco. Open your compass up to whatever those measurements are. Put the bullseye over that city and draw a new circle. Remember, the earthquake should be where all three meet. If all three are not meeting, you screwed something up. I got 5,300. Yeah, that's good. Okay. Not cool. And my whole entire water bottle spilled. No, I don't. Because it's unscrewed, that'll screw it. It's not broken, it's just not closed. This